Hello, everyone. Today, I'm very excited to introduce a new discovery in physics. We found the smallest constant of the product of space interval, time interval, and energy. We all know in our universe, every object, no matter how big or how small, must corresponding certain time, certain space, and certain energy. So our new discovery will significantly affect the physics development in the future, especially for the theoretical physics development. Recently, our new research has published in Physics Astronomy International Journal. Here is the link. In this new discovery, we combine with fractal geometry. We can deduce very interesting result. So in this video, I will introduce our new discovery. Let's start with a very tiny black hole. We know if a single particle, they have a very big mass, and if we compress this particle to a very small space range, the particle will form a very tiny black hole. When they become a tiny black hole, its Schwann shared radius here, and the Compton wavelength. If we let the r, the radius, equal to the Compton wavelength lambda, then we can get a mass and a wavelength lambda. They are all constant. Here, G is constant of gravity. H is Planck's constant. C is the speed of light. Then if we let the energy E naught equals mc squared, and the space equals lambda divided by 2, and the time interval is here. Then we will get three constant. There's x naught, tau naught, and E naught. Their value is very small. Then we take these three small numbers, E naught, X naught, and tau naught, we multiply these three together. Then we get a K naught. This is a very small constant. We can calculate its number. It's very small. So we call this small constant is space-time quantum of action. It's STQA. Because this constant is very, very small, so we can reasonably make a assumption that the product of space interval, time interval, and energy multiplied together should be integer multiple of K naught. This is the STQA hypothesis. Then for all physical system, we can use this formula to represent the STQA hypothesis. Here, n is a positive integer. Then we can see the energy, the space, and the time should be all a function of n, because n is a variable here. Then we take E and X and tau have the function of n, like this. These three functions, Fn, Gn, and Hn. Because Ex tau multiplied together equals n K naught. And K naught is equal to E naught times X naught times tau naught. So the three functions Fn, Gn, Hn multiplied together should be equals to n, because n is a positive integer. So we can prove the three functions Fn, Gn, and Hn should have same form. It's a power function. So we get three functions, Fn equals n to the power of a, and Gn and Hn, we get n, a, b, and d. And also we have to let a plus b plus d equals to 1. Based on the STQA hypothesis, we can see the A, B, and D is a new variable. But the physical meaning, we need to do a more research, and we have a mathematical deduce on that. Right now, we take the space formula. The x equals x naught n power n to the power of b. Then we rearrange this. Then we logarize this formula both sides. We can get this formula. This formula is very similar to the fractal dimension formula in self-similar set in the fractal geometry. Is this one. If we compare these two formula, we can see here the capital N is a positive integer. If we find a book for the fractal geometry, then we can find the capital N here is a positive integer, and the lowercase n here is also a positive integer, and the r in this formula is a shrinkage rate is smaller than 1. In this formula, the x naught divided by x is also a shrinkage is smaller than 1. And in this formula, the 1 over b should be equals to d. So we have this relationship and this relationship. Then we can see these two formulas is exactly the same. Exactly the same. So the d is the fractal dimension for fractal set. Then we can get the result. The conclusion is for every physical system, for example, a particle, their space should be a fractal structure. We can calculate the fractal dimension is d. And also, we can recall the time formula and energy formula is similar to the space formula. And get the space, time, and the energy also have the fractal structure. And we can apply this fractal structure calculation to a real system. For example, we can calculate the dimension of the universe. We know that our universe, they have a total mass, and we convert this total mass to energy. It's 1.3481 times 10 to the power of 77 erg. And the age of the universe is 13.787 billion years. We get this second. And the radius of the universe is this. Then we can multiply the E, X, and tau for the universe then put into the SDQA hypothesis, the formula, then we can get the n value for the total for the universe. That's a very big number, 8.06324 times 10 to the power of 181. Then we can use the energy, space, time, the formula, then put all the numbers into there. Then we can calculate the A, the B, and the D for the universe. Then because the 1 over A is the dimension of the E, the energy, and 1 over B is the dimension of space, and 1 over D is the dimension of time. Then we can get these three numbers. We can see it's very close to 3. Then we round to the nearest integer. We can get this 3 dimension is exactly the 3. So right now we get a very interesting result. Our calculation get the space dimension for the universe is exactly the 3. This is very interesting. This one we just get a theoretical calculation for the dimension is 3. And we can also calculate the subatomic particle. For every particle, we can calculate their A, B, D, and N value. Here is a kind of the particle. They have a rest mass, electrical charge, and a spin angular momentum. For this kind of particle, we can deduce the formula A, B, D, and N like this to calculate the value, the parameters. We can use that to calculate the leptons, quarks, and some intermediate boson, and some heavy particles. Then we put the result in table 1. And another kind of particles, they have a rest mass, they have a spin angular momentum, but they don't have electrical charge. But they have a magnetic dipole momentum. For this kind of particles, we can deduce the formula like this. We calculate A, B, D, and N value. Then we can calculate, for example, the proton, neutron, and some other heavy particles, all the parameters, then put into the table 1. In table 1, we can see every particle, they have a energy fractal dimension here. They are all negative number. This smaller, this very close to -1, and the time dimension here is also decimal number, and all close to 1. The time dimension is all positive decimal number close to 1. And the n value for every particle is very big. This have 10 to the 16, 17, some the numbers is very big. And also we can have the beta. The beta is the speed of the particle divided by the speed of light. So we can see this, all the numbers is very reasonable. Then we can get a conclusion from our calculation. Every particle or the whole universe, and also we can prove for every system, they are all consist of STQA. Or in the other hand, we can see the STQA is the most basic unit of our universe. All the matters is formed by STQA. And based on STQA hypothesis, we can calculate all the parameters for every fundamental particle and for the whole universe. For the universe, we can get the dimension is 3. So that's very interesting result. And all the other parameters for the basic particle is very, very reasonable. So we can see the STQA theory is consistent, self-consistent theory. And also we can see the every particle, we can calculate their dimension, their space, time, and energy. So from the space point of view, the every particle is not a point of the classical mechanics. They are not a wave function, not a wave. They are in the quantum mechanics. So the particle is contains some STQAs. They in the space they have a fractal dimension space. They occupies a certain space range. So this kind of pattern is similar to the wave function pattern, but it is different because the fractal pattern we can calculate. We can definitely calculate the value. So we don't need the probability explanation of the wave function. So right now we get a new approach to explain the wave-particle duality. So we can reconcile the controversy between the locality of Einstein and the non-locality of Copenhagen. And also the STQA is in the deepest level of universe. So everything, every physical parameters can be derived from this theory, from the STQA theory, such as the time, the space, the energy, the electrical charge, and so on. Everything we can can be derived from the STQA theory. And we can see the space and time is no longer a background, no longer a fixed background, but the space and the time and the energy is interact each other. So this is agree with Einstein's general relativity. On the other hand, the STQA is a quantum. So STQA theory is a quantum theory. So that means STQA theory can combine the Einstein's general relativity with the quantum mechanics. So the STQA theory may be a new theory of quantum gravity. And the geometry, from the geometry point of view, in the deepest level of our universe, the geometry is the fractal geometry. So we currently use the geometry, the Euclid geometry, or Riemann geometry, or Lobachevsky geometry. They are all approximate description for our universe. So that means our new discovery, we get the new theory, the STQA theory, is a very useful, a very reasonable theory. It will deeply affect the development of theoretical physics in the future. Okay, this video will stop here. Thank you, everyone. See you next time.